Un médecin qui est aidé de l'intelligence artificielle est mieux armé que celui qui n'en dispose pas. Et l'inverse est vrai également. La machine a besoin, on l'a entendu dans ces conférences, des chercheurs et des cliniciens pour apprendre, pour développer ses compétences. Plus précisément, professeur Casimir, l'intelligence artificielle a besoin des réseaux d'experts pour évoluer.
Yes, of course. Our next speaker is Benoît MACQ. He's full professor at the University of Louvain, where he directs the Pixels and Interaction Lab. He is active in the field of image processing and artificial intelligence. His research is carried out in an international context involving in particular the École Polytechnique Fédérale de Lausanne, the MIT in Boston, and the McGill University in Montreal. Benoît MACQ is co-founder of the Trail Institute. He is a fellow member of the IEE and senior associate editor of the IEEE Trans on image processing. He was pro-rector of the Université Catholique de Louvain and co-founder of 12 spin-off companies. The title of his lecture is Coalitional Active Learning and Prospective Applications to Network Medicine. Professor MACQ, it's yours.
So I've added a word to my title, which is Continual Coalition Active Learning. So my claim and the claim of this talk is that we need new machine learning architecture. So in the past, the idea of machine learning was to collect a lot of examples. For example, on this image, there is a microcalcification in a breast. So you show a lot of image to the machine. And then after a while, the machine is learning, as it was explained by Yvan. And once the algorithm has learned enough, we use it for diagnosis or we use it in a medical situation. My claim is that the model has to be updated continually and that the model has to be handled not by one medical doctor, but by a coalition of medical doctors who have to share data and to share expertise to give this continual learning. Another claim in the talk is the claim of active learning. So the idea is that each annotation, each case, each data have not the same value. Some data are more informative than other data. Some annotation are more informative than other data. And the expert annotation is something very expensive. So we should ask the expert only when it is very worthy for the machine learning system. So that's the idea. Coalition, continual, and active. Active means that we will ask the medical doctor only when the annotation is bringing sufficient value to the model. So the old question was, will the AI ever one day replace the radiologist? In my field, I'm working in the field of medical imaging, but it applies also to other domain of medicine. And the answer, the old answer is, for example, Curtis Langloss in the RSNA 3 years ago said, and he demonstrated with some publication and some data that the radiologists who use the artificial intelligence will replace the radiologist who does not. So the MD who is using AI will replace the one who does not because he goes faster, he makes less mistake and so forth. So one of the cornerstones nowadays for the machine learning, specifically in medical imaging, but also in other fields, is the deep learning. The deep learning has really created a breakthrough in machine learning because we reach performance that was never achieved before deep learning. And deep learning, it's the winning in the AlphaGo, in the Go game. It's behind all the translation programs in Google. And it's, of course, more and more used in the field of medical imaging and in the field of medicine, in the field of radiology, in radiotherapy also, we use it a lot, for example. And I will take a very simple example, which is the classification and detection of tumor in mammograms. This is a case where people think that AI could really definitely replace the MD. So how does it work? A deep learning network, just a figure. You see there are many layers, and all those layers are taking more and more abstract signals from the image. So the idea is to take an image, to split the image into many parallel images where we search step by step. That's the why it's talk. We are speaking about deep learning. The idea is to have more and more abstraction in many layers, and it takes a lot of data to adapt the deep learning to a given situation, because we need to give a feedback. We need to feedback some data, some annotated data, to adapt all the parameters of the deep neural networks. And so deep learning, it exists nowadays, companies providing deep learning models to do breast microcalcification detection or breast mass detection, or many detection in radiology, in screening program, or even in treatment planning. For example, if you go to a radiotherapy, the organ at risk, the tumor, at least the organ at risk are using deep learning for contouring, and it's in the practice in clinics. But the good idea and the good way to use deep learning nowadays is to combine a whole image classifier with a local patch classifier. So the good architecture, the things on which we are working in our lab, is clearly to see the big picture globally and to look locally and to combine a global and local classifier in a one step. And this is the kind of architecture on which we work, and the kind of architecture that we are improving in deep learning for that kind of application. So the claim here is that the current status, it's a very recent paper which shows that artificial intelligence is, and deep learning, particularly in radiology, is doing better than one medical doctor. But if there is a second expert advice, or if there is a coalition of experts, then the AI is far behind. So the accuracy of AI is not reaching the accuracy of a double expert view on brain imaging. So that's a little bit troubling, and it seems that it's really important to keep the human in the loop, and that's what I will develop here, and how to keep the human in the loop with the less information, the less pain for the medical doctor involved in this AI-based screening. So the promising results are not reaching the accuracy that was expected. So a second hypothesis is that when you apply deep learning, so you see here in the previous paper, the model was working pretty well in some conditions. So if you are a very big hospital with a very standardized image acquisition, with experts which are well trained to annotate image, for example, by using the BIRATS annotation, if you are very strict and very well defined, you can reach a good performance. But when you deploy it in a varying situation, the model does not reach the expected accuracy. So the idea is that the model should adapt continuously to the evolution of acquisition techniques. The model should follow the guidelines, should follow the standards of image acquisition, and the model should never be a black box that is put somewhere. The idea of having continual learning is more and more in the practice of what we do for deep learning in medical imaging. The model should adapt to the guidelines. Sometimes a coalition of experts are deploying guidelines in their own way. We call that mine lines. And in some sense, the AI model, the deep learning model, should be a knowledge representation of a coalition of experts. That's really what we search for. If we have a group of people with the same habits for doing screening, the group of people having the same habits to do a radiotherapy planning, how they can share their knowledge, they should have a deep learning model or an AI model which represent the knowledge of the specific coalition. So to sell a black box coming from USA in Europe or from Japan to USA is maybe not the model. We need a continual learning, and we need an adaptation of the knowledge which is represented in the model to the coalition. And so the idea is, of course, to have a model that can help for reaching consensus in a teams of medical doctors. In fact, the vision of the AI of the future is the AI being an agent which is seated in the meeting room, sitting in the meeting room with the other medical doctor, and which participate to the debate to take the final decision. This is the vision, the long-term vision we would like to push on. So I would like to elaborate a little bit more about active learning. So to make efficient model, we need annotation. We need people showing things on image, or sometimes we need, if we have cluster of interaction, we need to have some data and some annotated data. So the annotation take times and take money. And so we should try to design system where the annotation cost is reduced at maximum. And this is the idea of active learning. The idea of active learning is to provide to the learning model the most representative example, the examples that engenders the disagreement in the meeting room after, in the consensus between the medical doctor, and of course the hardest example to find. And so if we do active learning, in fact, we will ask annotation to an expert by reducing the cost of the time of the expert, but we will also provide to the expert the most interesting cases. And if we do active learning, the expert is not waiting that the AI is doing the job. The expert is interacting with the AI and keep his or her own expertise at the maximum level, because it will be challenged all the time by the AI on the hardest case or on the case where there is disagreement. So if we look the model of the active learning, on the continual active learning, we have a machine learning model, a deep learning model. We have a set of unlabeled pool, and we can use the machine learning to label all and to solve and to screen all the easy data. And when there is something on which there is a doubt, we can ask the human annotator to provide a label and to improve the machine learning inside the loop. So the human annotator, the human expert, will provide at the initial step a certain amount of labeled image, and after a while, the system will be able to ask only the important signals, the important data to the human annotator. So there are in fact three methods to be able to use active learning. The first one is to use this deep learning model with several layers and to shake the model in some sense. It's to create some randomness in the model and to see for one particular case, if I have an image to screen, an image to diagnose, if the image is entering inside the system, if I modify very slightly the parameters of the model and that I get a diagnosis which is completely different, even if the perturbation of the model on the model have been very small, then this is a case on which I have a high uncertainty. So it's also possible to use mathematical tools to measure the distance between cases and to show if a case is very different than the other case, that it is important to ask labels to the medical doctors. And the last approach to detect what are the interesting image to label is the query by committee. So the idea is to make 2, 3, 4 deep learning models which are different running in parallel. And if they do not agree, to ask the medical doctor to enter a new label. So the labels are spotting, the best label are spotting by that way. And so if we apply active learning in mammography, we have done it in my lab, you see that if there is a random choice of inputs data, the convergence of the accuracy is very slow and can sometimes never reach the best accuracy which is achievable by active learning. So you see that after 200 labels, the active learning is going to an accuracy which is far better, and the required accuracy for screening is reached only by the active learning, while it seems impossible to reach if there is a random selection of data. So the idea is not only to do active learning, but to do also coalitional active learning. Some of you are already well aware about the idea of distributed machine learning. So the idea of distributed machine learning is linked to the fact that the data, the data that have to be used are very hard to centralize. And so the idea is to have the data remaining in the hospital and to have the model moving from hospital to hospital to learn on the data. The data are remaining in the hospital and the model evolves by traveling from hospital to hospital. This is distributed learning, and sometimes people are speaking about federated learning. Federated learning is a technique which allows to preserve the privacy and which preserve the ownership on the data, which is sometimes an issue. So the idea is that for that working, distributed learning or federated learning is not enough, because we need coalition. We need people who have the same range of quality. We have the same standards of image acquisition, of working together. And so that's a first issue to solve. So we need to handle the fact that there could be a various quality of the data set. We need also the fact that we need to incentivize the people to provide annotation and to provide data. And so that's the reason why there is more and more usage of blockchain, because the idea is that to each data provided to the model, there is a token that could be claimed later if the model has some value. And we need also to protect the model. If a model is shared inside a coalition, the use of this model has to stay inside the coalition and not go outside. That's the reason why the engineers are working on a mechanism to trace the usage of the model. And so an example is a publication that my team has published 2 years ago, and we are starting more and more to deploy that kind of approach. We have a project dedicated to proton therapy. I see Serge Goldman in the room, and we do a consensus between medical doctors through this architecture of trusted coalition by using blockchain for distributed learning. So the idea of going further than a simple federated learning is to have a system when there are local data which are stored. And the idea is when somebody is providing data, he will never provide data, he will provide an increment to the model, an improvement of the model. And the improvement of the model is always validated by one or more validators. So the validators are validating the model or their own data, and they are validating also the model or on a shared set of data between the different hospitals. So when the people are providing data, they will not provide data from the hospital, they are providing increments of the model, and the increment of the model is validated on a local data set and on a global data set. And we ask each time the model is improved to validate the system by the member of the coalition. And so the old question was, will the radiologist who use AI replace the radiologist who does not? And for us, the new question is how to elaborate, how to constitute trusted coalition, so that coalition of radiologists will replace the AI that does not use the medical doctor. So the whole question was here, and the new one is this. So a last word to say that this kind of approach with distributed learning, with coalition learning, with active learning, we want to deploy it, and Jean-Luc Baligan has been a driver behind that, on network medicine. And there is an attempt to propose to the Région Wallonne a strategic innovative initiative around that kind of approach. And there is currently a work which is ongoing with Jean-Luc Baligan, Isabelle Salmon, Michel Georges, to deploy that kind of approach for network medicine. But I think that I have taken all my time, and I thank you for your attention. Yeah. Merci.
Merci beaucoup. Désolée, je ne parvenais pas à remettre ma vidéo. Elle était capricieuse. Alors, nous allons commencer le Q&A. Je vois qu'il y a une question directement d'Ivan Seis. Ivan, you can ask your question.
Thank you, Benoît. That was a wonderful talk. And it also ties into a lot of things that we're interested in. So with regard to the active learning, have you also looked into what is called weakly supervised learning models, where you actually don't require the expert to annotate very detailed, but let's say on a more broader scale, so that the expert could annotate more in a given time budget?
Yeah, that's a good point. That's one of the challenge in the Trail Institute, the Trusted AI Labs, the group of 5 universities is tackling weakly supervised things. And also weak annotation are of very big interest, because we have also some works on in the field of medical imaging related to psychiatry, and there the annotation are very vague, not very good, and we have to do transfer learning and weakly supervised learning to handle the stuff. Yes, it's a good question, and it's a very exciting emerging field, this field of weakly supervising learning, and we have young doctors starting works in this field in the Trail Consortium. Yeah. Thank you.
Next question from Jean-Luc Baligan, Professor.
Yes, thank you, Vanessa, and Benoît, thank you for this brilliant demonstration of how you can apply your mathematical tools and artificial intelligence in the medical field. I have a very naive question regarding coalition learning, because if you want to improve the AI diagnosis by submitting difficult data to a coalition of experts to try to improve the model, how do you account for the fact that experts can make mistakes, and how do you control for that? In other words, can we even improve the quality of the diagnosis by having some external validation? Yeah. I mean, I'm thinking as more as a biologist than as a doctor, but
that's not at all naive. Huh? I've gone very fast on the validation of the model, but the idea, oh, sorry, Jean-Luc.
No, go ahead.
Okay, so one of the idea, and it's not at all naive, it's very important, it's how to validate the quality of the data annotation if we centralize the data annotation somewhere. So imagine that you have a hospital which is creating its data warehouse when there are a lot of annotated data. It's very important to have a validation of the provided data. And for example, in the field of radiotherapy and proton therapy, we use validation by seniors from juniors. The work of the juniors are validated by seniors. And we ask not only to validate, but to sometimes to rank. When we have multiple annotation on the same case, it's very difficult to say it's good or not good. But it's always more easy to see this one is number 1, this one is number 2, this one is number 3. So to do a ranking in the quality of annotation is very good. So our idea would be to not only tokenize the annotation, but also to tokenize, to give incentive on the validation of the annotation. And we try to see how we could do that. So we know that medical doctor needs to have points, accreditation points, and so forth. Maybe we could have one day accreditation points to contribute to an AI model and to validate annotation of juniors in a deep learning model. And that could maybe a way to incentivize people to participate to that kind of things. But maybe I'm naive on my point for this aspect of getting accreditation points by contributing to the validation of annotation in a deep learning model.
And the following question will be from George Casimir, Professor. Oh, George, we cannot hear you, Mr. President.
Okay, it's probably
yes, better.
Thank you, Professor MACQ, for your very interesting talk. The Mayo Clinic says nobody is big enough to be alone. And I think it's a good example in your talk. But what is the qualification of the team and how much profession must cooperate to be the most effective in the future in this field of the development of artificial intelligence in clinical use?
So it depends. If you are doing a simple screening, you don't need a lot of different experts if you are doing breast screening. But if you have complex diseases in the field of neurology or in the field of cancer, the cancer board is running in every hospital nowadays with a multidisciplinary team. And of course, the final decision is not only the decision of a deep learning model. The final decision is a consensus between the participant to the cancer board, including a representative of the patient. And so I think that the model, if the model can help and can predict what will happen for the patient, it would be a big value to increase the value of the final decision when there is a treatment plan. If we do reinforcement learning on a treatment plan, we can predict what will happen with this treatment plan. And so AI can inform better the cancer board and can inform better the deliberative process between the cancer board and the patient. And so, in fact, we have to be very modest with AI. AI has to be a tool to find new patterns, a tool to help diagnosis, but the final treatment plan has to be in the hands of the coalition, as I said, the group of people who have to take this final decision. And so that's the reason why I don't think that the approach that is followed by some startup to provide a black box to people by saying we have that such amount of accuracy in our paper and we are publishing in RSNA that we reach such an accuracy or such a precision in our treatment plan is enough. We really need to have AI which is appropriated by a team and which is transformed itself by a team. The AI has to represent the knowledge of the team and to help the team to think better. That's the point here.
Thank you very much.
Thank you, and of course you will stay with us. Thank you to all our speakers for these fascinating lectures. But we will now continue to explore these topics through the round table.